This chart shows the life of a carbon atom. It discusses the different places you will find carbon and how it moves from one location to another. The carbon dioxide in the atmosphere, here's the atmosphere, here's the carbon dioxide in the atmosphere, come from a variety of sources. It can come from the ocean and from respiration. It could also come from deforestation. Or we can make it worse by burning fossil fuels. Carbon is taken back out of the atmosphere by things like dissolving it in water, photosynthesis to grow the plants, or by planting more trees by reforestation. If you notice at the very bottom here, it shows how carbon is under the earth as sand, silt, rocks, and fossil fuels. These pretty much stay there until we dig them up, which then adds even more sources of the carbon cycle. You may have noticed that the atmospheric carbon dioxide came from a variety of different sources. Some of them are natural, some are not. This pie chart shows the breakdown of the different unnatural, so these are the emissions sources of carbon dioxide. It seems that these categories are distributed fairly evenly. For instance, power and heating stations are 28%. And then we also have industry, which is 24%. Both of them are approximately a quarter. Deforestation, another 22%. Transportation, 17%. In order to decrease the carbon dioxide, not only do we need to decrease the use of the items here, but we also need to create what's called carbon sinks. These are items that take carbon dioxide out of the atmosphere, like planting more plants. A more accurate way of determining the amount of carbon dioxide is mass. Until recently, we have been referring to it as volume. But what if the gas molecules are either more spread out or more compact? For instance, here, they're really close together. Mass is a more accurate way to determine this. In fact, the previous slide, we're referring to the mass of carbon, not the volume, because sometimes it's found as a gas and other times as a solid. These items do not have the amount of molecules in them, and therefore the same volume. But each atom of carbon will weigh approximately the same. We begin to discuss the concept of a mole. Think of mole of an element as a way to count the atoms. The word mole in Latin means heap or pile up. This is how the word mole was chosen. By definition, a mole is 6.02 times 10 to the 23rd particles, which means 6022 which this is how many particles are in 1 mole of a substance. That is a heap of atoms. But all of these combined only weigh 12 grams. That was the atomic mass here of carbon. We spent a lot of time specifically talking about carbon dioxide. Let's take some time to discuss the other greenhouse gases. We'll come back to the molar mass, or to a mole, later. To simplify calculations, scientists and engineers relate the greenhouse gases to carbon dioxide. So you notice here, global warming potential is 1. That's because everything is related to it. That's the baseline. Global warming potential represents the relative contribution of a molecule of an atmospheric gas to global warming. Carbon dioxide is given the baseline of 1, while others are compared to that. Let's take a look at this chart. Carbon dioxide is at the top. Notice the GWP is 1, is a reference number of 1, in which all others are compared. Also notice that the concentration was dramatically increased since the industrial age. It went from 270 parts per million to 388. The main sources for this greenhouse gas is combustion of fuels, deforestation, and cement. Methane, which is the next one, is 21 times more influential for global warming than carbon dioxide. Its concentration has more than doubled since 1750. It comes from rice paddies, waste stumps, livestock. If you ever drive by a landfill, you'll notice some pipes sticking out of the ground. These are vents for the methane gas so it doesn't build up. Nitrous oxide is the next one on the list. It's 310 times more affecting to the global warming than carbon dioxide. It too has increased dramatically since 1750, but not nearly as much. It comes from fertilizers, industrial production, and combustion. Finally, CFCs are on the list. Notice before it's a 0. Now it's 0.56 parts per billion. That's because it's man-made. It wasn't even around before. It is 8,100 times worse than carbon dioxide for global warming. It's found in coolants and foams, such as refrigerators and air conditioners. So, what we know about global warming. Carbon dioxide contributes to an elevated global temperature. The concentration of carbon dioxide in the atmosphere has been increasing over the past century. The increase of atmospheric carbon dioxide is a consequence of human activity, and the average global temperature has increased over the past century. That's what we know. What we think might be true is that carbon dioxide and other gases generated by human activity are responsible for the increase in temperature, and the average global temperature will continue to rise as emissions from anthropogenic, remember this means human activities, greenhouse gases increase. Do we have time to wait for them to figure it out? Do we want to see how high the temperature will get? Can we afford to do this? That's why we have to act now. This is called a precautionary principle. It means to have the wisdom to act now even in the absence of complete scientific data, before adverse effects on human health or the environment become significant or irrevocable. These are the factors that affect Earth's incoming and outgoing radiation. You'll notice the 0 going down the middle. Everything on the right warms the Earth. These include carbon dioxide and other greenhouse gases. Ozone and solar irradiation or brightness. Irradiation here means brightness, how bright the sun is. On the left are things that cool the Earth, such as the reflection. This means reflection. So the clouds reflecting the light. The absorption of the UV radiation by ozone in the stratosphere. And aerosols. These are little aerosols. These are little specks like clouds and fog and such that absorb the radiation. These graphs show the representation of temperatures globally, only on the land and only water temperatures. So this is overall. This is just the land and just the ocean. The black line represents the actual temperatures. Now notice the difference between the pink line, the black line, and the blue line. The blue line is the predicted temperature that the Earth, if humans did not intervene. So the blue is if we never existed. So the temperature should have stayed pretty much constant. But because we came around, the temperature skyrocketed. Now take a look at the pink line. Notice how much closer it is to that black line. This is the predicted value if we only consider the humans and not any of the natural forces. So you notice how much of an effect that the humans actually have. Now this graph shows the possible predictions for the next 100 years. These are 4 possible predictions. The black line on the left is what actually happened, what we know. But the 4 on the right are the possibilities. Both the blue and the green line here show what could happen if the population increases to 9 billion but then taper off for one reason or the other. The orange line on the bottom shows the future trends if everything remains today the same as today. The temperature would remain pretty much constant, maybe elevated a little. And then the red one spikes up. And that's what would happen if the population continues to increase, but in a very slow movement towards cleaner energy. They all, however, even the small one on the orange, they all go up. Recognizing the problem of potential global climate change, the World Meteorological Organization and the United Nations Environmental Program established the Intergovernmental Panel on Climate Change in 1988. This was open to all UN and WMO members. In 2007, the IPCC, which was, once again, the Intergovernmental Panel on Climate Change, stated that the report that scientific evidence for global warming was unequivocal and that human activity was the main cause. So we are at fault for this. After meeting in 2007, the IPCC report gathered and analyzed the data for global warming. They decided that it was likely that the global warming was caused primarily from emissions since 1950. It is very unlikely that the change is a result of natural changes alone. Take a look at this table on page 139 to examine the conclusions closer. In a study that examined the polar ice caps, notice the change there. Scientists realized that the ice is melting at an alarming rate. Perennial, or year-round, sea ice in the Arctic is declining at a rate of 9% per decade. As the oceans warm, the ice thins, more solar energy is absorbed by the water, creating positive feedbacks to lead to fuller melting. So in other words, it just keeps melting and melting and melting. Such dynamics can change the temperature of ocean layers, impact the circulation and the salininess, how salty it is, the salinity or how salty it is, change marine habits, and widen shipping lanes. As a result of these changes, the ocean life and biodiversity is being affected. As the animals' habits change, so will their ability to survive. Global temperatures also result in melting glaciers. This then makes for a reduction of fresh water since a lot of the people rely on the glacial runoff for drinking and irrigation. The changes in the oceans can create changes in jet streams. This could create more extreme temperatures, which means more droughts, more heat waves, and an increase in diseases that accompany high temperatures. We need a way to lessen these greenhouse gases. The picture here depicts a way in which we can reduce carbon dioxide that is emitted into the air. This process is called carbon capture. The carbon dioxide is then filtered into carbon dioxide and put into the ground. This is one example of a climate mitigation, which is any action taken to eliminate or reduce the long-term risk and hazards of climate change to human life, property, and the environment. Although the future seems bleak, there is hope. The government is working hard to create regulations on individual countries' emissions. There's a lot of work to get done, but knowing is half the battle.